One, 1, 2, 3. Can you hear me? Dimitri, is okay? You hear me now? I think it's low, no? 1, 2, 3. 1, 2, 3. 1, 2, 3. It's okay now? Good. So wait a few more minutes. One, 2. We have 5 minutes and we start, okay? Good. 1, 2. 1, 2, 3. Okay. One, 2, 3. Okay. One, 2. 1, 2. 1, 2, 3. 1, 2. 1, 2, 3. Dimitri, can we start in half a minute? Yeah? Hmm? Okay, so can start now? Okay. Dimitri, we start now? Okay, good evening, Dnipropetrovsk.
Wait a second. I will announce you.
Okay,
So
sorry.
thank you guys for coming. Today, well, I hope some of you were here yesterday. So yesterday we had a talk about the front-end stuff, and today we are going to dive mostly in the back-end stuff, the one how we build systems, and Kfir is going to tell us how to do it correctly and fun. Have
Thank you.
fun.
Thank you very much. Good evening, Dnipropetrovsk. I came today to the city, and I already love it. Thank you. And this presentation was done this week in Build Stuff conference, which was fun in Kiev. Usually they make it in Lithuania, and this time they put in Ukraine. It was very good challenge for me and to see their presentation. Okay, so my name is Kfir. I've been working in the industry for 17 years in various projects. 5 years ago, I joined Wix, and in this time we make Wix to be a microservices solution. In this presentation, we go over how you will know when to break your monolith, and also I'll give you some tips for starting and the best practices. I have my Twitter if you want to have a question, and also I'll be around if you have more questions after the talk. And today I'm leading the engineering of the backend, and we also have the team here, so that's it. So, about Wix, few words. So Wix is a website builder, do it yourself. Everyone can build websites, your friends, your parents, no skill set is required. You just drag and drop and have your site. It can be static site, it can be a dynamic site. We have customized solution for a specific vertical. For example, we have hotel solution. So you can have a hotel and you can build a website for the hotel. And we have e-commerce for shopping online with cart and management and purchase everything. And we're also building online presence for small businesses. So it's fascinating, but I'm not going to talk about Wix. Let's talk about microservices. Just to get a sense of how microservices help us, so let's see the numbers. So we have 72 million users that are actually building websites. Take into account that we have a lot more people that are actually going to the website. So it's quite big. We save about more than 2 petabyte data of images and PNGs, all the things that go to the site. It's the static information. It's what we save now in our grid. We have 3 data centers, 2 in USA, 1 in Amsterdam, and we have also 3 major clouds that we are working on. Everything is deployed there. We serve every day more than 2 billion HTTP requests in our servers from the internet. And we are now 1,000 employees. When I joined, in the backend team, we were 3 guys, and now we are 1,000 people in Wix. And about R&D, we have 350 engineers in Wix. The major R&D is in Tel Aviv, and we have growing places in Dnipropetrovsk, which is here, and in Vilnius, and we are hiring good people. Our stack, so on server side, we do Scala. Recently, we are now exploring architecture for adding a Node.js in between for the front-end APIs. Client, we have React and Angular. And this is important. We are a TDD shop, fully TDD. In some cases, on the server side, we don't even have any manual QA. And we continue delivery. We deploy to about 20,000 deployments per year. Why I'm telling you this? Because microservices help us to be in this place. Okay? If I speak fast, you can stop me, have questions. It's okay, okay? Okay? You okay so far? Good. So, as I said, we came to Wix. We had, in the beginning, in the back days in 2010, we had a monster wild dinosaur monolithic server, one server that do everything. We were suffering from I have a low availability. Because we have no availability, we have fear of deployment. Because we have fear of deployment, we had long life cycle. And during this time, we moved toward microservices. And it helped us scale the software with what we be today, scale the people to be 1,000 people and 350 engineers. It helps us to meet the requirement of the life cycle of the product. And I'm going to show afterwards how it does. And it also makes Wix like a startup, and I'm going to talk about it more. Okay. So, anyone is here using a microservices? Okay. So let's go on definition of microservices. Before that, I want to show you, just to get a high-level view of what we're doing in Wix. This is partial list of the services, and it keeps growing. As we speak, it keeps growing. We also all the time putting more services in production, which talks to each other. So instead of having a monolith, and what is microservice? Microservice is the new buzzword. Everyone speaks about it. We will talk about it in every conference with your colleagues. We want it. Everyone wants microservices. So what is it? From Wikipedia, microservices is software architecture style in which complex applications are composed of small, independent processes communicating with each other using language-agnostic API. So this is the high level. What is microservices? I'm not agree that it's small. You can have microservice which is big. It's a comparison to the monolithic area. Microservices are built of many aspects. It's not like one thing. You're breaking your monolith, and all these things and many more is give you the ecosystem of microservices. But in my talk, it's not part of it. I want to give you the sense when and when not to decompose your monolith, because now we have big monolith, a big dinosaur, you're suffering, many people work on the same things, and you want to break it. I won't tell you when, because I think people are misuse microservices by breaking the wrong stuff and doing it in the wrong way. Sometimes less is more. Sometimes you don't need to break, because like any other things that you do, it's sometimes a trade-off. So before you're going to chop your monster to 1,000 pieces, know that it's a trade-off sometimes. I want to go over it before we start to do a breaking. I want to know what are the trade-offs for microservices. So first thing, it's IHOP. In the back there you had a monolith. Everything was concise. You work in the same process. You have, your if, your else, your branches. Now you have few services talking to each other. You're going for the network. It's the first time you go into an uncertainty situation. You really don't know what's happening. Network can be problematic. DNS routers are incorrectly configured. UPS is breaking electricity. The remote server is hang. No sockets. It's really uncertainty in situation. You don't know what's happening. In monolithic application, everything is okay. It's just get the request. You get the if-else. Of course, at the modern languages, you have Stack Overflow. You have memory leaks. But you know what you are going to. You know what the exceptions. Now when you go out of the network, it's really messy situation. You don't know. Partial deployment. Now you deploy a new feature. You develop it. It might be that this feature is being developed in few services, not only one. How do you deploy it? It's problematic. Now in the monolithic, you just deploy the server and that's it. Now you have service that has many parts because it touches many things on your server. What can do? Ops. In the back days, you have a bash script. You install your Tomcat or Jetty or whatever. You want to deploy, you just replace the files. It's yours easy. Now you have hundreds of services on 1,000 servers. It's a complexity. You need to get it automated. How can you handle it? Interfaces. In the back days, you want to add parameter to a facade or class, just do a refactor in your code, in your IntelliJ or in your Eclipse. You do a Shift F9, replace the parameters, everything is working. Now, in the microservices, you have strong interface. with services talk to each other, what you can do, it's problem. It's not like, it's a different thing. It's like a different paradigm. And last thing, end-to-end. End-to-end was easy. Testing was easy in Monolith. You just run the server and everything is running. Now you have thousands of services. So we have trade-off, and we can recover them, do mitigation. So for the IHOPs, you need to learn how to configure your HTTP clients. You want to do socket timeout and request timeout. You might want to do an asynchronous request. You can do many things. You want to do retry, you can do one retry. You know that most cases if you do one retry, you solve 80% of the problems. It will work. But you want to do more retries. Maybe you want to retry with delay. Maybe you want to do retry with exponential delay. It's different. And if you do retry, you must be idempotent because you don't want to have multiple side effects on the remote servers. So you do multiple retries and you have idempotent API. And you might want to have a circuit breaker. So you have client-side load balancing and you want to be more fault tolerant for you go on the network. And monitoring, of course, is now a different situation. You want to monitor because now you have a request that goes to 20 servers. You want to do monitoring. And eventual consistency. In some cases, when you want to do some critical thing, and no one is waiting for response, you can do eventual consistency. And more things like self-healing and persistency. So you can do something to reduce the problem of the IHOP because you have uncertainty. Partial deployment. So you can have feature toggle. You know feature toggle? You know feature toggle? Feature switches? You know what is it? You know? You don't know? Feature toggle is a mechanism using continuous delivery that you have like a database of something which has bits and you can open. So you deploy the version and the feature toggle is off with a new version. Then you can open it. You can open it gradually. You can every time close it. You can open it to some of the system because new features are new risks. And new risks now deployed to many servers. So you have feature toggles. Ops. Automation, of course, but now it's a totally different paradigm. Now, remember, in the back days, developers just do the code and ship it to the DevOps guy. Please, install my software. But now, it's different culture. We believe that ops are also our responsibility. The developer think of ops. Of course, you don't write the thing that installs the stuff, but you are the one that clicks the button to install it. You are the one that wake up at night because we have hundreds of servers. The ops guys, the new team, the small team cannot handle it. Now it's different culture. It's a cultural thing. Developer doing the ops. For strong interfaces, you need to think of backward and forward compatibility. You can't change a API. You can add more parameters with default values. In the back day, when you have monolith, you just change it. Now, think of backward forward compatibility. You need a proper contract test. So you know when you change interface in one service, the other service will break and let you know, whoa, you make a disaster, you break the interface. But I told you that you have trade-offs. I told them what are them. I told you how to mitigate them. But in the end of the day, there is still a risk. Another service, another failure point. You need to remember what you can do. But we come here to talk about microservices. And we want to do microservices because it's good and it helps us. It helps Wix, it helps the industry. Google, it helps Netflix to be more resilient and be more flexy. So know the limits and be advantage of them and know what you're doing. So, to be or not to be? This is the question. And now I want to go over with you on the 4 motivation when to break your monolith, because I think this is the most important thing that we need to know. When to start decompose things, and let them isolate and decouple. So the first use case I want to talk about is decoupling to gain resource isolation and high availability. What does it mean? In the first use case, we have an online shop service. Service that save a catalog for an online store, e-commerce store. And it has some APIs for updating things, update items, delete items, update price, handle inventory management. You can have inventory for your items. It also has API for uploading files. For example, you have your shop, you can upload the item of the, let's say you sell t-shirts, so you upload the items. Not surprisingly, the items go to this database, and the files go to the file storage. So, everything is clear, and in some point in time, boom, that's no problem. What's happening now? Our server threads are now being busy and waiting for the network. And server losing its resources. What's happening? Client cannot do like critical mission. For example, now let's see that the site owner, the online manager shop, wants to get a call from his vendor and said, I cannot give you more t-shirts to sell. I cannot give you. So I want now immediately to close the inventory. He cannot do it. Oh, sorry about this. He cannot do it. So you see that we have a situation that some non-critical API influence a critical API. I call it SLA. SLA is like importance of the API. SLA is something that's defined by your product manager. We are a developer in charge of make the isolation, not to be competition on the resources. So SLA can be many things. For example, SLA can say, this API must respond within 20 milliseconds. Otherwise, give me default. For example, unfortunately, I used to work in the telco industry, and we developed a solution, a feature that when you call someone, you can customize the tone that is listened, of a song or something. So the SLA there was says, answer in 20 milliseconds, otherwise give me a default. Some SLA says, I can wait for 2 seconds, 3 seconds. Some SLA can says, try to do it now, otherwise make it afterwards. Some SLA says it can be virtual consistency. It can be done in some point in time. We don't care. No one is waiting for it. It also relates to CAP theorem. You know what is CAP theorem? You know CAP theorem, in a few words, how to choose between availability and consistency. So SLAs belong to it, and you need to choose your SLA. And by doing it, you need to decouple your services and not let them compete on the resources. Resources can be threads, can be IO ports. You want that your critical APIs will work all the time. I know that you can say, all of my APIs are good. I want all of them, but you can't have all of them. There is some API that's more important and some less. So you want to isolate them. And this is the most canonical use case. Decouple your service by SLA. And okay so far? We okay? Good. So the next, let's see the solution. So we have the service, and we decouple it to second service. And if the network is down, this can still working. If the file service needs some data from the item service, it can just easily query it with APIs. So we have non-critical service getting information from critical service. The second thing is life cycle. Okay. So again, we have the same online shop service, and now we have coupons. What is coupons? Coupons is a certain logic that change all the time. Our product guys keep changing it. It has some logic that makes the company makes more money and conversion for more money. You can change the coupons during the holiday for Christmas or for weekends or for Black Friday or whatever you want. So coupons are changing all the time, and we have dedicated developers that keep writing these logics. So what will happen? Let's look at the life cycle of this deployment. At 4 p.m. I deploy this service. I add some catalog stuff. At 5 p.m. I deploy a coupon feature. We want a coupon. We have Christmas. At 6 p.m. I make some changes for the Black Friday. At 9 p.m. I decide to have another coupon for another company. So I make a change. And then we have the problem. We found a bug in this service. In this service. So what's happening now? We roll back the version, and now we came to a point that we have the version before this 4 p.m. and we lose what we deployed after 4 p.m. So company loses money. It's the case that few APIs from different life cycles sharing the same service. By decoupling it, we give the flexibility of services to be deployed independently. So in this case, I have the coupon service. It can be redeployed over and over again. And I have the item service, which can be deployed and rollback, we don't care. But this one is, and also by having them in the same service like before, we have a risk. Every time we deploy a coupon, we have risk on two other things. It's a risk. So remember, decoupling services also by life cycle. Okay? Depends how important it's, how frequent you need to deploy the APIs, and then make it a decoupling. The third thing is what we do all the time from university. We are using logic. We reuse logic while we do code, we do classes, we reuse logic by do function, while we do components, and we also can reuse logic with microservices. In this case, we have the same item catalog service, which has some geo functionality. So the geo is a function that for given IP, it returns back the country code, the city, and map coordination. It also has database, so it can cache the IP with the results. So for next time, it can read from the cache and so on. So let's say now another service need the geo. What do you do? Decouple, decompose. So now we have a third service of the geo. Both services has runtime dependency on this service. Everything is fine, yeah? Okay, but most people make mistake. They say, I will take this logic and use it here as a component, as an NPM of Node or jar or whatever, or RubyGem. So both services has the same code, which dependent on, and something weird going on. Both of them are using the same database. Now let's say we have 20 services that fetching and resolving the geo. All of them going to database. We break the rule of microservices which talk to each other by their interface. Now we have someone that go below and let them connect by database, so-called. So it's not good. So when we started decompose weak services, we get the rule that, this is for, yes? We get the rule that each service has its own database. Now let's say you have 20 services talking to database, like this. How do you monitor this? Okay, I want to monitor the geo. Let's look on 20 services to solve the goal blocks. By decoupling it outside, you can monitor it. Each service has its own persistence. Don't break services, trusted boundary, and APIs. They talk with the interface. Don't talk from database. Make sense? Another use case for not to decompose. Let's say we have two services that has some logic of deserializing a cookie. Let's say we have a cookie of the user with some encrypted data, and it deserializes it. So two services are doing this deserialization. Does it make sense to make it another service? No, because services are deployable artifacts which has ops and IO dependency. You don't want to pay with IO hop when you can do something small on the CPU. You want to reuse and things that has some implicit things like database and so on. So you don't need to decouple every small piece of CPU bound logic outside. Everything is certain. An exceptional case to do it is when you have a service that, let's say, you do some high intensive CPU with 3D and so on. But it's not the case. We're doing some cookie installation. We're doing CRUD operations. Tested code which run on CPU bound is very, very consistent. Okay. Last thing I want to decompose is by having team responsibility. Okay. So I want to tell you a fact. 90% of projects are failed. You will never be on time. Content are incorrect. You have bugs. We fail. We don't. We give the time. We lose. Fail. But this article says if you want to make it 70%, make smaller team. Smaller team, 3 to 5 people, and 3 to 5 months per project. It's a fact. So decomposing to support organization scalability. Do you know Conway's law? Have you heard about Conway's? So Conway's law is talking about this thing that you're also engineering your people and you break your organization to small teams and have them a responsibility. Large team cannot handle large code base. Of course you can do it with GitHub, but who is the owner? Now I work on many things. How can I divide the tasks? We want accountability. We want people to feel ownership. We want people to feel they own something. We want them to feel a small task. For example, e-commerce, hotels. I want them to feel ownership. So we break it to small things. And the most important thing for my presentation, I want you to know that even though that your company size is corporate-ish, you want people to feel like startup-ish. End of the day, when I joined 2 weeks, I joined when we were 3 people on the backend guys. Now we are 70 backend guys. People are still feel like they are in startup because we break them to small team and small responsibility. When you break your monolithic to small services and small teams, if you still have big team, continue and decompose. Make them small team. You hire more people, you have team of 10 guys, continue break them. Break the team, break the services. It goes together. Now I want to talk about now Wix organization. We are made of guilds and gangs. So gangs are like small companies. For example, one gang is the e-commerce. They do the e-commerce site. one gang do the hotel sites, all these hotel logics and so on. Each gang's made of backend guys, front-end guys, product, marketing, UX, designer, and so on. Like small startup. We couldn't support having this guild and gang stuff without microservices. Let's say now we want to put gangs and we have monolithic. Who is take off deployments? They depend on each other. We let the gangs run by their own. Let them run and be independent. Of course, in the big graph you show on the microservices, they still might get some core data from core services. But let's say, for example, the e-commerce. They are here also. They're in charge of 5 services. The shopping cart and the catalog and the API gateway and so on. They're independent. They have their own challenges. Small companies have challenges. They do core stuff. They do CQRS. They have big data in some cases. But they are independent. They are concise. They have the ownership. We couldn't make this culture without make the gangs without microservices. I want to recap what we've done so far. So I said we have 4 motivations to decompose our service. The first one is the SLA. Know the SLA, know the importance. Decouple your services by knowing what is important, what is not important, and make them not compete on the resources of the machine. We talk about reuse the code. How do I reuse the code? I will decouple things outside onto deployments and reuse the code. We talk about lifecycle. Know the lifecycle. Continue. If you want to do like Wix and deploy 20,000 deployments a year, decompose your stuff to small things that have different lifecycle frequency deployment. And the last thing, and Conway's law and all this stuff, is have a small team. Keep yourself startup. Make people feel their owner. Make them accountability. Make them wake up at night if to fix the bugs. Make them architect. In Wix, we don't have architects. Wix, we have, everyone is an architect. You work in a gang, in a team. It's your project. You are the architect. You are the manager. You are the ops. You wake up at night. Microservices help you gain this. Okay? So, the last thing of my presentation is I want to talk about you have a monolith and you want to do it with caution. You want to break it up. I want to give you some practices. Before that, I want to ask if you have questions so far. Everything is clear? Yes, please. You want to give the... Yes.
I have one question. For example, what you do if you have one big task, so which touches like 5 or 6 microservices, and each of microservices depends on each other. So you should deploy first microservice with new feature. After that, you can deploy second microservice, third, and there are a lot of dependencies. And what should you do in such with such?
Okay, good. So as I said in the trade-off, testing is complex. Because in the back days you have monolithic, you just run the server and do tests. Now, like you said, you want to run 100 services, Docker machines in testing? So no, but I want to go back to the slide of the services to show you. Okay, so let's take the e-commerce example. You see, we have 5 services on the e-commerce. So in this case, for example, most of the features are touching this. Of course, it can talk to other services, the e-commerce, but most of the features touch, in this case, So our end-to-end test in this case, in the TDD lifecycle, will run all the services. So when you do a feature, you write the test and you run all the services within your test. So you know what's going on. If you want to do some refactor on your test phasing, you will know what's going on. Is that answer your question?
Yes.
So you don't move all weeks together in your testing scenario, but you load things that are in common and share the same strategy, like the e-commerce, 5 of them together. Make
And
sense?
second question is about development environments. For example, on microservices, you need, I see 20 Dockers, for example, Docker environment, and how you handle these environments. So do you have some servers which automatically set up all this environment for development, or each developers create tests, for example, checks his microservice and thinks it will be okay, it will work with another.
Okay, so we don't run any service in any machine of the user. We're working in TDD. So the first thing we want to have new feature, we write the test fail test. But for running this test, we need a server, we need a database. So our testing environment, loading everything, the test has its setup. Once you do git clone from the repository and you run your test, you can make sure everything is running. You can run the Mongo, the MySQL, the Elasticsearch, the Redis, everything is run embedded, or we run it executable. So you don't care. No need to install anything. Your testing environment in TDD, having all services you need. Now if you need, for example, this one needs this service, I want to answer this one. You don't want to run this service because you need it. What we do, in microservices, you have standardization. In Wix, our services talk to each other with JSON RPC. You know JSON RPC?
Sorry?
JSON RPC, you know? JSON RPC.
Ah, yeah.
So we make an abstraction, the JSON RPC, we make an abstraction in Wix that we have a framework that lets you just create a Java interface or Scala trait. Then you call that the service, the interface. And below it will be JSON. So in this case, if you want to use the App Store, the e-commerce, if we run a service, a generic service Jetty, and we give a mock for this one, a Mockito or Jamok or whatever. But remember, it will still do the HTTP call because it's not real mock. It's a mock after the HTTP of the server. So you run this thing and this thing, you run it if you are the e-commerce guy, but you run real services in this case because this is what you're doing. Every time you touch all of them. But you can do mock and this, HTTP mock. So it's like, and if they change the interface, this will break because it's a strong typed Java or Scala. Oops, sorry. Okay, that answer your question?
Yes, and the last third question, how often becomes such situation? For example, one developers from different teams have agreement. One developer says we should do this way. Second developer says yes, we should do this way. After that, they have implementations. They have they're using same API, but they want, for example, some miscommunication or such problems. So one team implemented protocol in one way, second team implemented client for different way. They deploy it and need to redo everything.
So because this we have standardization. You can do gRPC of Google with protobuf. You can do JSON RPC. You can do REST. We have standardized in Wix how services talk to each other.
So every error, every corner case should be standardized and
yes.
Have documentation.
If I need something for this service, before I start it, I need from you the user ID or the user email. So we create the interface. I depend on it. That's it. I know it. Then they can deploy it and they can work on the implementation. But from day one, you know what is the protocol. What is it's like? It's strong protocol. Make sense? More questions? Will we continue? Or, yes, please.
Sorry for my bad English. I try to ask my question. Let example that you have two services that communicates between each other and they have some version of API, you know, right? So let be two different services that need new version of API. It's different services, so we write a new version and deploy it, but all service still running with old API version. You understand, right?
Yes.
So how many version you support at all for all of these services?
You can have 100 versions. The idea is always to add new functions and not change the current function. Once all deployed, you can start open gradually, but the idea is you can have thousands of versions. We don't care. We remove the old version only when you're confident and we have few months running and so on. So you can have many versions of API. For example, you want to have new API and this and use API this. It's new API. It's different.
But what about database structure? How I can support? Yes.
That's why I said that database is not a fact. It's hiding. Each service is database. The interface that matters is the watch HTTP that you expose. Database is underlined. It's a database. We don't care. It has interface. Strong. That's it. You want to have more do new function. You don't expose database. It's concise within together. Make sense?
But if inside one microservice service I have changes in database structure, so how I can refresh all dependent services?
You
for
shouldn't.
API structure.
You must support the API that you have for them for good. Let's say for this service, you now want to change database. New structure. It has API that is it's a contract. It can make it duplicate. You can say, I will remove it within a year or something, but you must support it. You must support. You can tell the guys, I have new API. Please go to it. And in some point in time, they will move to it. But you must support. It's different. In monolithic, you can do it. If you change everything inside, you must support all the API. You cannot change it.
1-2 version back I can support, but when it's 5-6 version of different APIs, it's crazy.
You can have hundreds. Now it's matter of engineering. You need to make your code that everything goes to the same function that does this logic. It's a matter of engineering. It's engineering stuff, but in practical day, we change one version API, and because we are flexi and we have continuous delivery, we cannot people change your API and then do it right away. So we still need support because I don't want them to do rollback. But you can send an email to the guys. I have new API. Please go to it. They will go to it. Then you can remove it afterwards. Okay?
And can I ask yet another question?
Please.
What about access to API? How you store users like microservices users that can connect to API? How you can notify all of them? How you know who use your API just now?
So it depends on your trusted boundaries in your organization. In Wix, everyone is trusted. We have metrics and we know who calls to which service. We can generate reports that this service being called by this, this, and this. We can get the report. We have mechanism for security. You don't want to have strong authorization between your company. You want that everyone can use our services. You want them. You don't want to have, okay, this one, please provision and send me. No. We are open. Everyone can do. In terms of security, we have security, and everyone is trusted boundaries. These services are not in the internet. They are inside Wix, inside the services between, not outside services. So everyone can talk all to everyone, and we can generate reports that says this is connected to this one, and so on. Make sense? One more question? Yeah, please. And we have more things, but it's okay. Okay, please. Please.
So you said that you have some different SLAs on your interfaces.
Yes.
And you also said that you're using probably HTTP, JSON, RPC.
Yes.
And I think that if you have different SLA, maybe you have different ways of not only this ad hoc HTTP, but maybe like bus or something like that.
Yes.
What
Exactly.
is that?
So in some cases, we are eventually consistent. So in some APIs, it must deliver in some point of time. In the CAP theorem, we are consistent. So we have message bus. We used to have, and we still have, ActiveMQ, And now we're moving strongly to Kafka. We have Kafka cluster with Zookeeper and high availability. So good question. We do have event bus, and we do have RPC is good, as you said, for the client, their request, get a response, we're waiting. Some cases we want it consistent. So we're also using the event bus for doing self-healing process. For example, let's say you have a service, and you have another service to do indexing. Let's say a search. You have the app market, app store, and you have a search. So search is the free search, you put Elasticsearch, and the apps, you can do query by categories. So updating the search might fail. So we do eventual consistency. We use the event bus. Search by nature is eventually consistent. It's okay if it's not returned right away, but in a few seconds, no one care about it. Okay, makes sense? Answer you? Good. More questions? Yes, please.
Do you have some problem with performance? For example, if you have one single database, you can use indexes, joins, and so on. But if you have different services, for example, to get some last 5 feed items from some specific users, you should fetch, for example, 5,000 or 1,000 users, for example, or at first from JSON RPC, after that do something in second service and third service, and it can be really slow.
It's a good question. There is things around cascading failure. This is microservices. First thing you say, cascading failures. You have 20 hops. One of them is slow. So again, you need to match the timeouts. So the first service went for 20 seconds, next one 19, next one 18. You must match them. In some cases, you need to have default values. You can do asynchronous. If not can't respond, you do whatever you want. So it's a big issue. In some point in time, everything is configured properly, and you know how much you wait. For example, you have services that full hop takes 2 or 3 milliseconds. Nothing. But cascading failures, it's an issue, and it's in another presentation, not in this one, but I can tell you that you must match the timeouts, and you must be more fault tolerant in this case. Okay?
But anyways, some tasks can be done with different services. They use some denormalization, for example, storing same data on different services for performance to solve performance problems.
Okay, we have one use case. The two services have the same database, but only one of them reads. Yes, it's true. Sometimes you want to have performance, and it's okay to say with SLA, this service cannot depend on anything. This service must have only database. That's it. It's okay. In one case, you can say, I don't care. You can have 4 seconds. You can go 20 hops and 40 hops. We don't care. So it's really a situation you need to think. If you want to have zero dependency, and you can also make exceptional. You can have, okay, for example, in Wix, the service that serves the site having the same database of the service that publish it. So, but we do it on purpose because we want to have performance. And in rare case, because we are engineers, we are architects, we are developers. Engineering is not the deterministic thing. You can make exceptions. You need to think what you need, make an exception. Okay. More questions?
Good evening. I try to explain what I think. For example, we have application monolithic, which contain several microservices. For example, we update one of them. How did you deploy this updated code to microservices? This code will be running on a lot of containers, or for each service should be running only on one, exactly one machine.
No, everything is n+1. For each service, you have n. It's not like one service. So n+1. It's everything is n+1. We have 20 of these, and 10 of these, and 5 of these. Everything is not like having a service does not say that they have one server. It have services that has same strategy, but you can have many services of the same service, many servers running. Okay, makes sense. More question? We can continue. Yes, please.
I'm sorry, I return to previous question about joins. I think if you need a joins in microservices, like SQL joins, not if you understand what I mean, I said about SQL joins that can work when your application architect like microservices. Yes, so you can use search engines for replace SQL joins and run it like and cache it in search engines in indexes.
Okay, I want to answer this again. There is 2 strategies for making data from 2 places. One, like you said, you can have a cache. What do you mean? You have one data authoritative place, which is database, and you have another service that have duplication of data, duplicate it, and it can have self-healing, and it can have update it. Another use case of joining is calling 2 services and get them merged. But again, if you have paging, it's problematic. So it's okay to have the caching pattern. So we have one service that have data, other one other data, and if you need both of them, you can have a snapshot of both of them. But that alternative is other services, so they can rebuild it from scratch anytime. Make sense? More questions before we continue? Yes, please.
Have you ever experienced a problem with message bus? For example, when the load is too high and the queue is just out of memory, and how will you scale it? For example,
Yeah, I tell you, it's ops is always a problem. We still have problem with IDMQ. That's why we moved to Kafka. Every time you add another dependency, you need to learn the ops. You know that the code of C3PO, connection pool of MySQL in Java, it's thousands of lines that's been written for 10 years. So you need to know the ops. We have problem when we need to dive into how to fix them, but that's why we need to try to find more things to resolve. Now we move to Kafka, which is more resilient and more high throughput. And we found that ActiveMQ is not scaling out, it's scaling up. So we need to have big servers. So it's, yes, we have a problem, and it's not like a trick solution. You need to know the ops. It's not need to know and try to learn it. It's not like a tricky solution for this. More question? We'll continue. Yes, please.
What was the most challenging, like the biggest problem you solved while moving from monolith application to microservice?
Again, what's the question?
The main problem, I think, the main problem you were stuck on while moving from monolith to microservice.
I think it's a cultural thing. The last things I'm going to talk, it's maybe answer you. If not, I'm going to ask again. I'll continue talking about how to make it, what is the fear, and okay, I will answer. It's the next part of the presentation. Okay, can I continue? Yes? More question? Okay. By the way, Pavel, I forgot to put the recording for the screen. Sorry about this. Okay, so let's go on. It takes a while, many slides. Okay. Okay, so make changes gradually. Be safe. Remember the gear, when you extract the gear stuff? So now we have service. It has gear functionality. Everything is working. Now I put second service. We go to uncertainty. We don't know what's going on. So what we do, we develop the gear, and we're still reading the gear from both services. We try the new service. If not, we fall back to local. Only when we are confident that our gear solution is going, we move the traffic to it. So important thing when you move to monolithic to microservices, do things gradually. Make things slowly. You can roll back it at any time. You have feature toggle. Going to new service, you have unconfident, you're going back in time. Another thing, if you don't want to lose your job, don't start from the most critical point. Take a service which no one cares about. Of course we care about our services, but let's say, for example, in our online shop, we have a feature that suggests similar items. Okay? So, if it's not working, no one will fire you. It takes a while until you make confidence. So, start with services that if they won't work, the company is still alive and make money. Because you need to learn. It's an educational process. You need to learn what you're doing. It's different paradigm, different culture. Confidence built slowly. You need to educate the company, your managers, about this. You need to talk about the terms. When you deploy a service of the Geo, it's your first service. Talk about the term on the emails. Talk about confidence not only for you. It's for you, of course. It's for your managers. It's for your VP marketing, for the marketing guys, for product guys. They have monolithic. Everything is working for them. But it's a cultural thing. You need to make them confident. How you do it? By talking. I have new service. You talk the term. How the Go service is up. How you have the metrics of the Go service. And talk. It takes a while. I tell you something. In weeks, down the road, we had many deployment freeze. We have unconfidence in a moment, but by talking and educating the company of microservices, things are done, but it takes slowly. It takes time. It's not like magic microservices like this. It takes a while, and wait, and talk about the things. Monitoring. I showed you in the beginning the balloons of microservices all these things that making the ecosystem of microservices, you don't need all of them from day one, but monitoring is your key, because if you have API that goes 20 hops to 20 services, parallelize, fork and join and everything, and you have a bug, you know how to look at it. You don't know. In the back days, you have your log file on your monolithic server. Now you have, it goes back and forth in the gear and in the upmarket and all this. So monitoring is the first thing you want to develop. You want to have metrics. You want to have, in Wix we have a request ID which chain in all requests. So we can have another tool with Kibana and Logstash, and you can have, for given request ID, give me all the hops and the logs so we can make it together running. Monitoring, something you want to start with. Last thing, talking for education. We have process in Wix, we call it postmortem. Every time you have downtime or rollback or something, we have this process and we talk about the problem. The guy on the team that makes the deployment talk, and we have sit 5, 10 guys in the room, managers and colleagues and so on, and talk about the problem. It's not blaming, it's education. By talking about the problem, of course you learn how to not make it next time. But by talking, we're educating the organization of how we have the problem and how we failed them, what is the pitfalls and so on. So talking not for blaming, talking for educating and for us. Of course, it's like action items, and once you fulfill them, you have more confidence and more availability of our services. But important to talk. We also have a retro on Thursday. Retro session. We will sit in circle, 50 server guys, and we're talking. What is the things we didn't? What is the wrong? What is the right pattern and so on? Talking is important. I will finish with says, you must start from some point. Microservices are good. It helps you build the organization, recruit people, keep the company startupish, give people ownership, support your life cycle, support your SLA. But start from something. It's like a diet. I want to start a diet tomorrow. I say, tomorrow I'm going to start diet. I stop drinking, but start from something. This is what I want to tell you. Start from something and make it happen, and educate your colleagues and manager. Questions? More questions? Yes, please.
You said, for example, that development should be slowly. We should speak with managers. That we should talk about APIs, internal APIs, and so on. But managers, for example, I know one success story when managers fired all Python developers with TDD and so on, found PHP shitty coders which implemented some monolith applications. It worked, and company received the money. So managers can say, okay, you're fired. I'll find PHP developer, and it will implement monolith applications for 2 weeks, and it will give us money. But from business side, for example, I can say that because it will give me money faster than creating some.
Okay, if you create a new company and you want fast 2 months, do a monolith. I suggest you to write the right abstractions so you can break them afterwards easily. You have your classes and everything. But once you face the problem you saw in the I/O and stuff, you can tell your manager, we need to break it. But if you're a good engineer, and I believe you're good, make the abstractions, make in your code inside the monolithic, then you can break it out. Okay? More questions, please?
I want to ask about monitoring. In my one of company where I work, we have many different fails with Zabbix, for example, and many different mm, not really important messages. What you do with thousand and thousand messages when Zabbix agent is down and just not responding and something like this? How you control it?
Good question. First, you need to filter your basis exception, not the runtime exception. You can filter them. In Wix, we use New Relic, you know? You know New Relic? You know New Relic, you know? We use New Relic, so we can see the exceptions, different them. We can hide. We always have exceptions that you accepted, so you can hide some of them. But again, you don't want to have when you have 1,000, you ignore all of them. You want to get only the. So it takes a while until you learn how to ignore stuff. It takes a while, and you want to get exception when they are really painful. When your disk is down, when your memory is down, when database is not responding, you want to get them. And if you get bursts of exceptions, you really have a problem. In the back time, 3 years ago, my mailbox was full of shitload of exceptions that no one really cares. So developers configure the New Relic, configure the Graphite, Anecdote, whatever tools to get what is important to them. Okay? More questions?
Anyone?
Thank you for inspiring talk. I would like to ask about the process more. And you've told that you have like everyone is an architect and you grow rapidly.
Yes.
So in this condition, often happens then different team do different stuff, and as a result becomes like a Frankenstein. Do you have any internal, I don't know, special processes to keep everyone aligned?
First of all, we want to give everyone to be independent. But we have something called Wix Framework, which is our baseline. We have there the RPC. We have there all the aspects we keep between processes. We have there all the cryptography inside. We have there all the file configuration loading. So we must standardize your baseline. You want that all company develop the business. For example, e-commerce doing amazing stuff. They're doing here in Decomposing. They're doing CQRS, event sourcing, and wild stuff. But you don't care about the standardization because we give them by the framework. So when you want to develop something in Wix, you have the framework, and you develop your own thing. So framework is keep changing and give you more functionality. It's also challenging because you need to be compatible and you need to not to break anyone. But it's important that the microservices and the gangs will be focused on the logic. And if they develop some infrastructure, it's okay. Once other guy will need it, we're going to extract it out to be a framework. So a rule I like to say, never start developing a framework. Develop something you need. If anyone else needs it, take it out and move it to a central place. In Israel, we have something called it ready for all condition. Every time in Israel, in the back days, it's hot, you know, Israel. So the old air condition was a hole in the wall, and you put the air condition in the hole. You don't have money for air condition, so prepare for air condition. You make the hole. Don't do it. Do what you need when you need. If anyone else needs it, move it to the framework. Okay.
More questions? Come on, guys.
You can ask as much as you want. It's okay.
So I wanted to ask it before. The same question this guy asked, and it wasn't probably answered. So I would ask it a bit differently. So this process of moving from monolithic, like MVP application, like when you're small, and to some bigger microservices thing, it's long journey. And you took it, and maybe you have some, maybe not troubles or like bad decisions that you took, or maybe there was some funny things in this process while like changing the way you work and change your applications.
Yes, for example, the first thing we learn, let's go back to the slide I like of the services. Wait a second, I need to look for it. Okay. You see there is the yellow and the blue. We've learned that we need different database. What problem that once you edit a site, and sometimes one guy needs to view it. And we got into a point that we must have database, different one. So there is no two-person connection database. It's one thing that we learned. So everything is divided into public and editor segments. And the testing that we found in the way, the cascading failures, because it took us a while to configure the HTTP. How do you do HTTP? How do you do connection pools? How do you do retry policy? How much do you know? How to configure your ActiveMQ? So I don't can give you a like this solution, but in any place you can think about, we had problem with database, with persistency, with eventual consistency, with all this stuff. We always have problems. It's in any case I talked about. It's from real cases that we have problem. We need to tackle them. Okay. But I can be available. You can talk to me by email and so on. Okay. I'll give you more details if you want. Okay. More questions? So I want to say something for the finishing. Oh, wait a second. Sorry. Wait a second. Well,
Keynote is slow.
well, it takes a while. Oh, we finished already. Yeah. So I want to say thank you, and I want to say that we are hiring, and we are putting a lot of effort on engineering, and we believe that we need to be good engineers and invest on our engineering. And I want to say again about the guilds and gangs. So we have the gangs, is the companies. What are the guilds? The guilds are, for example, let's take Pavel. Hi, Pavel. He is developer in the gang of the e-commerce, but he also belongs to the guild of the server guys. So the guild is the place of the professionalism. So every Thursday in weeks, once a week, you leave your project, your company, and you work for the guild. We do retro, we talk about things, we contribute things to the framework. So everyone is contributing to the framework. So we do believe in TDD and do testing first and do continuous delivery and do this stuff. And we are hiring. So if you want to, if you have friends, good friends that want to join us, I will be welcome. And I'm leaving, but I will be available. You can tweet me or anything else. And any questions and so on. It will be fun. It was fun talking to you also. And thank you very much. Thank you.
And we have some beer and some pizzas back there.